What is a recursive function and how to use it? A recursive function is like when you want to the function to call itself until some condition. For example, we have this in math. We will have to do what is the 5 factorial. In real, how you develop this in math, or how you will do it by yourself, you will say that 5 factorial is equal to 5 multiplied by 4 factorial, right? So 4 factorial like this. And then you will say, okay, so now what is the 4 factorial? So you will say that it's 4 multiplied by 3. So each time to be able to handle n factorial, let's complete it to give it the full Control C, Control V. The 3 factorial will be 3 multiplied by 2 factorial, Control C, Control V, and the 2 factorial is 2 multiplied to 1 factorial, and the 1 factorial equal to 1. So now you know the result of 1 factorial. You go back to multiply it by 2. So we return here to multiply by 2, you turn here to then the result will return here to multiply by 3, then the result will return here to multiply. As a process, what did we see? If we have n factorial, it's n multiplied by n minus 1, right? And where we stop once we have 1. So we will do this repeatedly. I don't know what is the value of n, so we can put some dots here to say Control C, Control V. We will do it again and again until we arrive to 1 factorial is equal to 1. So what is this in terms of algorithm? It's like saying that we have a box, okay? Inside this box, what we will call it? We can call this box the factorial function, okay? And it take as input n. This is the input of the function. So it take as input n. So what will happen? First thing to do when you want to do a function, a recursive function, is to say, okay, when my work is stopped, what is the condition to stop calling, to stop the function to call itself again and again and again? What is the condition here? The condition is that if it's with the 1, so if n is equal to 1, let's say just equal to 1, okay, what will happen? We will return the result, return 1. So we are sure that once we have this condition, we return it. So we said that we should never ever forget to close the if. Here we will do the end if. So like that, we are sure that at this stage, once we are at 1, if n is 1, you will return the value of 1. But if it's not 1, what will happen? So what is the result of the function? The result should be equal to n multiplied, and we call the factorial again with n minus 1. Okay, and with this factor, what will happen is that, okay, if we are not at 1, we will call again the same function, factorial, it's with capital F, so to keep everything correct, with 1 value. So we will call the factorial with n minus 1. So we will re-enter the box of factorial with n minus 1 value, and then we will call it again. We will re-enter with n minus 1 value until we arrive to 1, because once we arrive to 1, the last one that we enter it virtually. This is how we imagine it. Virtually, we enter this last one. Okay, the last one give me back the 1. So then I will start to return one stage at a time, and we should never ever forget and function here.